Good morning, children. Today's class is based on the second theorem in the lesson, triangles area theorem. The statement is, the ratio of areas of two similar triangles is equal to the ratio of squares of any two corresponding sides. The word ratio defines as division. Basically, the word ratio means division. So, division of areas of two similar triangles. That means it is given that the two triangles are similar is equal to the ratio of squares of any two corresponding sides. Let's draw the figure and write the given and to prove condition. So, the figure says that triangle ABC, let triangle ABC and DEF be the two similar triangles. So, given triangle ABC similar to triangle DEF from the statement. What is to prove is ratio of, as I told you, ratio means it's a division, areas of two similar triangles. The two similar triangles are ABC and DEF. So, area of triangle ABC by area of triangle DEF is the same as ratio of squares of any two corresponding sides. If triangle ABC similar to triangle DEF, which are the corresponding sides? AB by DE, BC and EF, AC and DF are the corresponding sides. So what is to prove is area of triangle ABC by area of triangle DEF is, it can be either AB square by DE square by the word square, or it can be BC square by EF square, or AC square by DF square. So from the statement we could write the given and to prove. The left hand side starts with area of triangle ABC, area of triangle DEF. The basic formula in your mind for area of a triangle is half into base into altitude. Since the altitude is not given in the figure as construction, draw AG perpendicular to BC and DH perpendicular to EF. That is construction. Draw AG perpendicular BC and DH perpendicular EF. What type of triangles are triangle ABC and triangle DEF? It is given that triangles are similar. Let's start the proof by writing about similar triangles. Proof: since triangle ABC similar to triangle DEF, what are the two conditions? The conditions are angles are equal and the sides are proportional. AB by DE is the same as BC by EF is equal to AC by DF. Equation number 1, and the corresponding angles, angle A equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Equation number 2. Now, starting with the left side of to prove is area of triangle ABC by area of triangle DEF by the concept of half into base into altitude. Area of triangle ABC divided by area of triangle DEF is the same as half into base BC into corresponding altitude AG divided by half into EF into its altitude DH. Let's mark it as equation number 3. If you observe equation number 3, BC by EF is already one of the pair of corresponding sides, and if we are able to replace AG by DH with BC by EF in equation number 3, the theorem will be proved as area of triangle ABC by area of triangle DEF is equal to BC square by EF square. How to prove that the side AG by DH is equal to BC by EF? That can be proved with the triangles AGB and DHE. If you are able to prove those two triangles are similar, the proportional sides will give you AG by DH as BC by EF. Let's see how it is done. In triangles AGB and DHE, angle B and angle E are equal from equation number 2. Angle B is equal to angle E equal from 2. Angle 1 is equal to angle 2 is equal to 90 degree by construction. Therefore, triangle AGB is similar to triangle DHE by AA, similarity. Let us write the proportional sides as AG by DH is equal to AB by DE. One more pair is there, GB by HE. For the time being, we are not writing. AG by DH is equal to AB by DE. Highlighted. Now, from equation number 1, what is AB by DE is equal to BC by EF? From 1, what is AB by DE is equal to BC by EF? Highlight that also. That is, AG by DH is equal to AB by DE became equal as the proportional sides of similar triangles, and AB by DE is equal to BC by EF became equal as given condition. Thus, what can you say? Therefore, AG by DH is the same as BC by EF. You proved it. Substituting in equation number 3, the theorem is proved as area of triangle ABC by area of triangle DEF is the same as BC by EF into BC by EF, which is the same as BC square by EF square. Similarly, if the altitude is drawn to the sides AC, DF, we can prove it as AC square by DF square, or if the altitude is drawn from the vertex F to the opposite side and C to the opposite side, it will be proved as such. Exercise 6.4 is based on area theorem, and for application of basic proportionality theorem, we were taking a triangle and a line parallel to the base of the triangle, and we were applying the ratios. Whereas before applying area theorem, the very important condition is the triangles should be similar. If the triangles are not similar, we should prove them similar by any one of the similarity criteria we have done in the previous exercise. Question number 1. Let triangle ABC similar to triangle DEF and their areas be respectively 64 centimeter square and 121 centimeter square. If EF is equal to 15.4 centimeter, find BC. It is already given that the triangles are similar. It's given that triangle ABC is similar to triangle DEF and the areas are given, the measures of areas are given. Directly we have to apply the formula and then get the missing side what they have mentioned. Proof is area of triangle ABC divided by area of triangle DEF is the same as any pair of proportional sides square we should take. They have mentioned on EF and BC. We have to take it as BC squared by EF squared. This is on area theorem. Area of triangle ABC is given as 121/64 and area of triangle DEF is given as 121. 64 divided by 121 is the same as BC has to be found out. EF length is given as 15.4 square. The calculation, if you take the square and cross multiply, it will take a long time, but most probably the numbers given here will be square numbers. 8 square by 11 square is the same as BC square by 15.4 the whole square. By taking square root on both sides, 8 by 11 is equal to BC by 15.4. BC is equal to 8 into 15.4 by 11 and it is 1.4. 8 4s are 32, 3, 11.2 centimeter. Try to avoid multiplication and division. Most of the time it will get simplified by the numbers. Question number 2. Diagonals of a trapezium ABCD with AB parallel to DZ intersect each other at the point O. If AB is twice CD, find the ratio of areas of triangles AOB and COD. Diagonals of a trapezium ABCD with AB parallel to CD, and one more condition is given as AB length is twice CD. AB length is twice CD. The diagonals intersect at the point O. Find the areas of triangles OAB and OCD. The proof, given condition is AB is equal to twice CD. The triangles, we have to find the areas of triangle AOB and COD. Now, if you have to apply area theorem, the triangles should be similar. It is not given that the triangles are similar. So, the first step is to prove that triangle AOB similar to triangle COD. In triangles AOB, COD, angle 1 is equal to angle 2, AB parallel to CD, alternate interior angles. Angle 3 is equal to angle 4, vertically opposite angles. Therefore, triangle AOB, write the position properly, AOB similar to COD. Triangle COD. So what are the condition is AA similarity. So now you can apply area theorem. Area of triangle AOB divided by area of triangle COD is the same as the ratio of any squares of any corresponding sides. Here AB and CD is mentioned. So let's take it as AB square by CD square. Replace AB with twice CD. 2CD the whole square by CD square, which is the same as 4CD square by CD square, or the answer is 4:1. Here you can mention that it is based on area theorem. Question 3. In the figure, triangle ABC and triangle DBC are two triangles on the same base BC. If AD intersects BC at O, show that area of triangle ABC by area of triangle DBC equal to AO by DO. The figure is given to you. Let's draw the figure. That is, triangle ABC and DBC are two triangles on the same base BC. So if the base BC is considered like this, triangle ABC and triangle BDC are drawn on the same base BC, and if AD intersects BC at O, if AD intersects BC at O, to prove is area of triangle ABC. What is to prove is area of triangle ABC divided by area of triangle DBC is the same as AO by DO. AO by DO. Here, when you check area of triangle ABC, AO is not an altitude. Same way, if you check the triangle BDC also, DO is not an altitude, to apply the concept of half into base into altitude. Let's draw the altitude AG for triangle ABC and DH for triangle DBC. So the construction is, draw AG comma DH perpendicular to BC. Now directly you can apply area is equal to half base into altitude. The proof starts as area of triangle ABC divided by area of triangle DBC is equal to half into base BC into altitude from the opposite vertex AG divided by half into base is BC, altitude from the opposite vertex as DH, and you cancel, put it as equation number 1. Now, to prove is area of triangle ABC by DBC is equal to AO by DO. How to make sure that AG by DH corresponds with AO by DO is by proving the triangles AGO similar to triangle DHO. If you can prove it as in triangles AGO and DHO, what are the two angles here? Angle 1 is equal to angle 2 equal to 90 degree by construction. You have constructed the altitude. Angle 3 is equal to angle 4, vertically opposite angles. Therefore, triangle AGO similar to triangle DHO by AA similarity. The proportional sides are AG by DH is equal to AO by DO. Proportional sides of similar triangles. Substituting in 1, the final answer, area of triangle ABC divided by area of triangle DBC is equal to, instead of AG by DH, you are substituting AO by DO. That is the proof of question number 3. Question number 4. If the areas of two similar triangles are equal, prove that they are congruent. If the areas of two similar triangles are equal, prove that they are congruent. So what is the given condition is, the first condition is triangles are similar. Triangle ABC similar to triangle DEF. And one more condition they said as their areas are equal. Area of triangle ABC is equal to area of triangle DEF. What is to prove is the triangles are congruent to triangle DEF. Now, the given conditions are triangles are similar as well as the areas are equal. Proof. Let's start with the given condition. Area of triangle ABC is equal to area of triangle DEF. Area theorem is always a ratio of areas of triangles. How can we make this equality sign as a ratio is area of triangle ABC by area of triangle DEF can be written as 1, because if you cross multiply, it is the same result. Now, using the first given condition, the triangles are similar. Can we apply area theorem for the proportional sides of this triangle? Yes. Here, the first proportional side is AB square by DE square. That value is 1. Or BC square by EF square can be 1. Or AC square by DF square can be 1, all by area theorem. That is, we are applying area theorem on these two triangles ABC and DEF since the triangles are similar. From here, AB square and DE square are equal, which shows that AB and DE are equal. Similarly, BC and EF are equal, AC and DF are equal. In two triangles, if all the sides are equal, by SSS criteria, the triangles are congruent. Therefore, triangle ABC congruent to triangle DEF as SSS congruency. Very important 3-mark question. Question number 5. D, E, F are respectively the midpoints of the sides AB, BC and CA of triangle ABC. Find the ratio of areas of triangle DEF and triangle ABC. DEF are the midpoints of AB, BC and AC. D is the midpoint of AB, E is the midpoint of BC and F is the midpoint of AC. It is given in the question. Find the ratio of areas of triangle DEF and triangle ABC. To prove is area of triangle DEF by area of triangle DEF by area of triangle ABC to find. Next is, if you have to apply area theorem, we should prove the triangles are similar. How can we prove that the triangle DEF and ABC are similar? Since the word midpoint is given to you, It is the application of midpoint theorem. If you recollect it, D and E are the midpoints of AB and AC. Therefore, DF parallel to BC, DF equal to half BC was midpoint theorem. Let's start with that. In triangle ABC, D and F are midpoints of AB and AC. Therefore, DF parallel to BC and DF is equal to half BC. It is by midpoint theorem. We will be taking only the condition of DF is equal to half BC, or we take the ratio as DF by BC is equal to half, equation number 1. Can we write the other proportional also, sides also? Can we write the other proportional sides also as DE by AC equal to half and EF by AB is equal to half, equation number 3. From 1, 2 and 3, DF by BC equal to DE by AC equal to DE by AB shows that the triangles are similar by SS's criteria. Therefore, triangle DFE similar to, when you are writing DF, it should be BCA. Similar to BCA by SS's similarity. If you are writing ABC, that is triangle ABC. A corresponds with E, B corresponds, it should be EDF. Any one way we can write. They are asking you to find the area. Therefore, area of triangle DEF by area of triangle ABC, DE by, it should be actually ACB. Area of triangle DEF by ABC, it should be area of triangle DEF with ACB. The triangle ACB is the same as DE square by AC square. You can see the corresponding sides here, which is equal to 1 by 2 the whole square, which is equal to 1 by 4. Question number 6. Prove that the ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding medians. If you remember exercise 6.3, question number 16, the last question, the proof was the same because they said already AD and PM are the medians. So this question is the same question as that one, but one more step by applying area theorem. Let's do it. Prove that the ratio of areas of two similar triangles is equal to square of ratio of their corresponding medians. So it is given that triangle ABC and triangle DEF are similar, and one more condition is the medians are AD and you can take this AG and DH. So the given condition, the first condition is triangle ABC similar to triangle DEF. Second condition, AG and DH are medians. What is to prove is area of triangle ABC divided by area of triangle DEF is the same as the ratio of squares of corresponding medians. Medians are AG and DH. we have to prove that they are AG square by DH square. The proof, as in question number 16 of the previous exercise, since triangle ABC is similar to triangle DEF, what are the conditions? The conditions are AB by DE is equal to BC by EF is equal to AC by DF, that is, sides are proportional. Regarding angles, A and D are equal, B and E are equal, C and F are equal. Now, prove the triangles ABG similar to DEH. For that, the first condition is AB by DE is equal to BC by EF. BC can be written as twice BG, EF can be written as twice EH. That is, AB by DE is the same as 2BG by 2EH. In triangles, we can mention the reason, since AG and DH are medians. In triangles ABG, DEH, AB by DE is equal to AG is equal to BG by EH, and angle B is equal to angle E, and angle B is equal to angle E from 2. This is proved. Therefore, triangle ABG similar to triangle DEH by SAS similarity. What are the proportional sides? AB by DE corresponds with AG by DH. Proportional sides of similar triangles. Now, apply area theorem. What is area theorem? Area of triangle ABC divided by area of triangle DEF is the same as AB square by DE square area theorem. Replacing AB by DE as AG by DH, it's the same as AG square by DH square. Number 7. Prove that the area of an equilateral triangle described on one side of a square is equal to half the area of the equilateral triangle described on one of its diagonals. Question number 7. You are given a square A, B, C, D. Two triangles are described, two equilateral triangles. One on one of the sides AB, let's call it as ABE, and the other one on the diagonal AC. That means with AC as one of the base. Both the triangles are equilateral. What we have to prove is area of triangle ABE is half the area of triangle ACF. It is given that ABCD is a square. Let the sides be all of measure A. So given ABCD is a square, triangle ABE, triangle ACF are equilateral triangles. What is to prove is triangle ABE is half area of triangle ABE is equal to half area of triangle ACF, or the ratio of area of triangle ABE by area of triangle ACF is equal to 1 by 2. Now the proof starts as, let AB is equal to proof. Let AB equal to BC equal to the same length A, because since ABCD is a square, all sides are equal, and for a square it is a right angle, and you can find the length of the diagonal by Pythagoras theorem. AC square in triangle ABC, AC square is equal to AB square plus BC square, that is AC square is equal to A square plus A square, or the value of AC square is 2A square. You can just highlight and keep. Now you have to find the areas. If you are required to find the areas, first you should see whether the triangles are similar. What type of triangles are? Triangle ABE and triangle ACF are equilateral triangles. What is the peculiarity of equilateral triangle is? All angles measures 60 degree. Therefore, the triangles automatically will be similar by AA similarity. Since triangle ABE and triangle ACF are equilateral, they are equiangular, therefore triangle ABE similar to triangle ACF by AA similarity. Now can we apply area theorem? Yes. Area of triangle ABE divided by area of triangle ACF is equal to AB square by AC square by area theorem. If AB is A, what is AB square? It is A square, and AC square is 2A square over area of triangle ABE by area of triangle ACF is equal to 1 by 2. This is the last question in area theorem exercise. This exercise, all the questions are very important. I request all the children to copy down the proof from the video and study it thoroughly, as almost all the questions are very, very important.